Okie dokie. So this is definitely one of my favorite pre-cal lessons. The unit circle. It's going to go on page 68 when we're done. Okay. All right, so we're going to start on the front here. Here we have two 30, 60, 90 triangles, which we talked about briefly the other day. So we know in the 30, 60, 90, we have a short leg and a long leg. Across from the 30 is the short leg, so this would be S. Hypotenuse is 2S. And the long leg is S times the square root of 3. So when we did these the other day, we substituted in 1 for S, and then we did some ratios with it. We could substitute in anything we wanted. For our purposes today, we're going to substitute in 1/2 for S. So when we do that, that makes our hypotenuse 1. And then 1/2 times the square root of 3 would be square root of 3 over 2. Okay? So we did it that way because we want our hypotenuse to be 1. Okay? And right now it's because it said so. All right. Okay, so I want you to take your two green triangles, and you should notice that they are labeled for you, just like what we just did. Put them next to each other in front of you, just like this little picture shows right here. Okay? We're going to get some things labeled before we move on. That way we can grab the right things when we need it. So inside of here, you're going to put a Roman numeral 1, Roman numeral 2, and then do the same thing inside the triangles themselves. Also draw in the right angles. I was going to go back and add those, but it's a lot more work than it seems, and I figure we get to draw them in. Okay? We all good on the green ones? You take the green ones and slide them out the way. Grab your two yellow ones. Put them next to each other like they are on the paper. And we're going to do the same thing, Roman numeral 1, Roman numeral 2, and then also do that inside the yellow triangles. Oops. And then slide them out the way. Okay, are we all good? Okay, so now we have 45, 45, 90. And to label those, that was S, S, and S times the square root of 2. This time we're not going to worry about what we're substituting in for S, because what we want is we want our hypotenuse to be 1. Now, I could just tell you what it is, but I want to make sure you understand how to find it if you needed to find it on your own. I have the two hypotenuses, I don't know, labeled, so they're equal to each other. So I can say S times the square root of 2 equals 1. And if I want to figure out what S is, I'm going to divide by the square root of 2. So S is going to be equal to 1 over the square root of 2. But I can't leave it like that. When I rationalize that, what would it be? Square root of 2 over 2, right? So if you grab your two pink triangles, you'll see that that's how they're labeled. Put them next to each other, like the picture down here. Roman numeral 1, Roman numeral 2. The same thing inside the pink triangles. Okay. And then you can move them out of the way. All right, so we're just kind of getting things set up right here. All right. Now, if we flip it over, and what we have in front of us here, if I can get this to zoom for me, I have a circle, obviously, but this in particular is a unit circle, and we call it a unit circle because the radius is 1 unit, okay, of whatever the units are. So that's what a unit circle is. Radius is 1. And we're going to put a whole lot of stuff on here, and we're going to need to know everything that's on this paper except for the degree measures. We don't really care about those, but I left them on there just because I know that still is what makes a little bit more sense to you, just for, reference purposes, but you're not going to need to know them. And it's going to seem overwhelming. Maybe I shouldn't tell you at the beginning we're going to have to know it all, but I'm going to show you today a lot of patterns that are in here and why it's not going to be that big of a deal to actually learn this stuff. Once we're done today, you're not going home and memorizing this stuff. You're not going to know it all today. Today, what you're going to get from this is understanding where the information is coming from and how to use this. The why we care, that's coming later, and how we're going to know it without stressing out, that's going to come later too. Okay, so you just got to stick with me, pay attention, ask me questions, don't let your brain shut down on me. All right? Okay, so I want you to take your Roman numeral 1 green triangle. Okay, and you are going to, we'll zoom in a little bit too much there. And you are going to place it down in the first quadrant here with that 30 degrees at the origin. And when you do that, it should fit real nicely where the 30-degree part is at the origin, and then this vertex where it says 60 is on that point, and it goes right on the x-axis. Okay? Then you're going to take one of your pieces of tape, and you're going to tape it down. Then you're going to reflect it down here, okay? And when you do that, see how it's a little wobbly? Okay, it can be wobbly. So we're going to fix it where when it's reflected down, it fits the same way. It hits the point, it's on the x-axis, and once you got it nice and straight, you take another piece of tape and tape that side of it. That way, when you reflect it back and forth, it shouldn't be all wobbly anymore. Okay, everybody okay with that? All right, so this 30 degrees right here, notice that the line segment it matches up with right here says 30 pi 6. So this point, if it rotates from here to here, it is rotated 30 degrees or pi 6 radians. So 30 degrees, this is one of those that I told you need to know that that is pi 6 radians. And it's okay if you don't actually know that yet. We have this to look at, and we're going to be okay. And this angle and this triangle is related to this ordered pair. Now, I want you to think about what you know about graphing and plotting points. Don't worry about trig. Don't worry about pre-cal, weird square roots. Don't overthink anything. You've been plotting points for years. Taking what you know about how to plot a point and the information in front of you, what do you think the x value of this ordered pair is? What would make sense? This one right here. Anybody brave enough to say something out loud? How do I get, where do you start when you plot points? At the origin, right? And then I would go to the right and I'd go up. So what would the x value be? How much do you go to the right? What's this length? Square root of 3 over 2, right? I'm going to go to the right, square root of 3 over 2, so that's my x value. And then what do you think my y value would be? 1/2, exactly. You see how that works? Okay, so now we're going to take this triangle and we are going to reflect it down. What quadrant is my triangle in now? 4. So we're going to put a Roman numeral 4 in here, put in our right angle, and this was pi 6 radians, right? Then we're going to relabel it. Our hypotenuse was 1. This is square root of 3 over 2, and this was 1/2. Okay. Now up here, this triangle represents pi 6. When we're down here, this angle is 11 pi 6, right? I would go all the way around to get to here at 11 pi 6. My triangle represents the reference angle. Remember the reference angle we talked about? The shortest way back to the x-axis? So for this 11 pi 6, my reference angle is pi 6, okay? Knowing what we know in front of us, what would this x value be? square root of 3 over 2. Okay, good. And since we're in the fourth quadrant, what would the y value be? Negative 1/2. Good. Everybody understand that? Okay, now in a perfect world, or if there was a way that I could figure out how to make this work, we would only have one triangle, because then we could, if I could attach that to a little teeny tiny point and it wouldn't fall apart, we could just reflect this over to the second quadrant. But, you know, we're dealing with paper triangles, so we can't. So we're going to pretend like we reflect it over. You're going to take your other green triangle and you're going to place it here. And we're going to tape it down. Reflect it, straighten it, and then put another piece of tape on it so that it'll reflect nicely. So when this is in the second quadrant, this 30 degrees still represents pi 6. This point has been rotated through the angle of 5 pi 6. My reference angle is still pi 6. Since I am in the second quadrant, what would my x value be? Negative, good, square root of 3 over 2. And my y value? 1/2. Okay. Everybody understand where all this is coming from? Okay, so then if I reflect this down, what quadrant am I in now? Third. So we're going to put a quadrant 3, my right angle, pi 6, and then let's get the measurements on there. Square root of 3 over 2, 1/2, and 1. So then what is this x value? Negative square root of 3 over 2. Good. And the y value? Negative 1/2. Very good. Because we know how the quadrants work, right? We know that in the third quadrant, x and y are both negative. The way quadrants work, none of that's changing. It's all the same stuff we've been doing forever. Now let's look at this big picture. There are 16 ordered pairs on here. We're going to have to know all of them in the end, which again is not nearly as scary as it sounds. We just filled in 4. But do I really have to learn 4? Aren't these just the same numbers over and over again? Just the signs change? So really of these 4, I only really have to know 1 and then understand how my quadrants work. Does that make sense? All of these represent pi 6 angles. So remember I said yesterday that we would talk about 5 pi 6. That's my second quadrant pi 6th angle. 7 pi 6 is my third quadrant pi 6th angle. Because these numbers are the same. We'll talk about what they are and why they care in a little bit, but they're all the same. I just changed the signs maybe, depending on where I am. But also notice that all of the pi 6, they are all the angles that are closest to the x-axis, and it's all about reflections and symmetry. All right, and so some of us are maybe more visual learners than others, but being able to kind of have a picture of this in your head and understanding where things fall can be very helpful, especially if that's your way of thinking. Okay, everybody good so far? All right, so let's grab your Roman numeral 1 pink triangle. Make sure your green one is flipped up. You're going to take this one and lay it right on top of the green one. Line it up all nice and pretty. Tape it down there. Then reflect it and straighten it. Maybe push it up to the x-axis there. And then when you tape this side, you're really just taping it right to the green one. And then it'll work just fine. Okay. So this is 45 degrees. What is 45 degrees in radians? It's right in front of you. What is it? Pi fourths. So what is 45 degrees in radians? Pi fourths. Okay, I want you actually saying it there. So we're going to put a pi fourths here. All right, so then for pi fourths, what is this x value? Square root of 2 over 2. And what's the y value? Square root of 2 over 2. Right. When we reflect this down, what quadrant are we in? Fourth. Get my right angle there, and this was pi fourths. So this is square root of 2 over 2, square root of 2 over 2, and 1. So since I'm in the fourth quadrant now, my x value, square root of 2 over 2, my y value, negative square root of 2 over 2. Everybody good with that? Okie dokie. Now let's take our other pink triangle. Make sure the green one is reflected up. Place this here. Line it up. Tape it down. This is pi fourths here. So in the second quadrant, my x value would be negative. Good. Negative square root of 2 over 2. And then my y value is positive, so that's just square root of 2 over 2. Right. When I reflect it down, what quadrant am I in? Third. Third quadrant, right angle, pi fourths, square root of 2 over 2, square root of 2 over 2, and 1. Third quadrant, I know my x and y values are both negative, so negative square root of 2 over 2, negative square root of 2 over 2. So, big picture again. All of my green ones, my pi 6, are closest to the x-axis. All of my pink ones, which are my pi fourths, are in the middle here because they're all related to 45, which is halfway through the quadrants. Okay, but everything is all symmetric. Now, again, we have 8 ordered pairs we've written down. We really only have to know 2 of them, and then we'll understand how to get the rest, right? Even though I have 2 ordered pairs I have to know, there's only a total of 3 different numbers, right? 1/2, square root of 3 over 2, and square root of 2 over 2. 3 actual numbers, but 8 ordered pairs. And you'll be able to know exactly where they fall. I'm going to give you easy ways to understand all that once we're ready for it. Everybody good so far? Okay, so you should hopefully kind of get the hang of how all this works. So then I want you to do your yellow triangles, tape them, label them, write your ordered pairs. Hopefully you can do all that without me talking you through it. If you have questions, though, let me know. Help each other if necessary. Okay, I know some of y'all are still writing and taping, and that's fine. I'm not moving on. Just going to start talking. As you're doing this, or when you're done, I want you to look at your yellow and green numbers, which I know y'all's aren't colored, but your pi thirds and pi sixths ordered pairs, and tell me, what do you notice about them? The same numbers, right? So we have 12 ordered pairs written down. I only need to know 3 to be able to easily figure everything else out. On top of that, when we just had 8 of them and only had my green and pink on there, we realized there's only 3 different numbers you have to know. 1/2, square root of 2 over 2, square root of 3 over 2. Once we added 4 more ordered pairs, is there an additional number you have to know? Nope. 12 ordered pairs, a total of 3 numbers. Okay? And then we just have to be able to let the numbers fall where they're supposed to, which again, will not be a difficult thing if you actually practice this along with me and listen to what I'm saying. The people that have trouble with it and the people that are going to complain about it are the people that aren't practicing or aren't listening or aren't looking at what I'm asking you to look at, that sort of thing. But there are bazillions of patterns in the unit circle. We're just kind of looking at some of them right now. I also want you to notice, and it probably would have been easier. Let me do it with a blank one. I probably should have said this before I put all my stuff on there, but while you're doing that, I'm just going to put a blank one up here. So notice like your pi thirds, right? I've got pi thirds is at 60, 120, 240, and 300. Or it's pi thirds, 2 pi thirds, 4 pi thirds, 5 pi thirds, right? I don't have to do the math with, like, the radians make more sense to be related to each other. And the patterns will make more sense with that stuff. And they're all the pi thirds ones are all reflections of each other, right? Pi thirds is bigger than pi sixths, that sort of thing. And that, like I said, I'm going to give you ways to be able to keep these straight and know which is which. But again, for those of you that are visual, when I start to ask you questions about pi sixths, pi thirds, I see, like, some people, like, literally I can see their eyes and their fingers go like this in the air because they're thinking around the circle. But some people, it's just kind of their eyes go because you're, like, visualizing it in your head, which is phenomenal. I'm not making fun of anybody. I'm saying that's a good thing to do. But if you understand the spacing and the numbers, if you're like, okay, I know that for the pi third or the pi sixth here, I have to go to the right more than I go up. And for pi thirds, I have to go up more than I go right, then you can that'll help you keep those numbers straight. Okay, so that's one of the many ways that I'm going to show you. All right, so is everybody caught up? Good for me to move on? You have a question, or what are we doing over there? Oh. All right, we still have 4 ordered pairs we haven't filled in. Okay, so we need to do that. What do we call this circle? Unit circle, because the radius is 1, all right? So that means this ordered pair right here, what do you think the x value is? 1, right? If the radius is 1, I'd go from here to here, 1 unit, the x value is 1. So what's the y value? 0. What's this ordered pair? 0, 1. What is this one? -1, 0. What is this one? 0, -1. Okay, would you agree that those 4 are probably the easiest 4? Okay, so when we start actually using this, and for our purposes we're going to, for some reason, those 4 are the ones that some people have the most trouble with. And I still haven't figured out why. If I could figure out why, maybe I could fix it a little bit better. But, sometimes I know you know the difference between x and y, but sometimes when we want this point, sometimes we say 0, 1 just by accident. That's not the kind of problems we're having. The problems that people have are like, they have no clue and make it out like it's the hardest thing they've ever done. Just think about your 4 quadrantals and like where those things lie. It's really just fine, okay? All right, so does everybody understand where these numbers came from? Came from our special right triangles. You can use this to flip up and down when we're trying to figure it out. Let's talk about what this applies to for us that we're going to use it for. So we're going to do some notes on here. We're going to go to the top. We're going to start at the top left up here. Oh, before we start at the top left, I want you to come back over here real quick. Your first green triangle, take your pencil and draw a line next to it. You can kind of use it as your straight edge. That way, when we reflect it down, you actually have a triangle drawn on your circle. You can put a little right angle there. And then here's our angle. So we're going to use this drawn in triangle to help us with some stuff. Okay. All right, now we can go to the top left. And let's talk about sine. All right, so sine of theta. From SOHCAHTOA, we know sine is what over what? Opposite over hypotenuse. Okay? Jenny. Opposite over hypotenuse. We all agree with that? So on the coordinate plane, here's my angle, right? This is the opposite side. This is the hypotenuse. So on the coordinate plane, the opposite side, this side right here, that's my y value, right? And the hypotenuse is the radius. So another way to look at opposite over hypotenuse, if I'm in the coordinate plane, that is y over r. But since this is a unit circle, what is the length of the radius? 1. So this is the same as y over 1, which means that the sine of theta in a unit circle is y. Here's why that's super important and super helpful to us. When I look back over here, and I'm going to use my pi thirds, my yellow one, the sine of pi thirds is the square root of 3 over 2. It's this y value right here. The sine of pi fourths is the square root of 2 over 2. The sine of pi sixths is 1/2. It's the y value of those ordered pairs. Okay, does that make sense to you? So that's how all this is going to be related to each other. Now, so that means here, this opposite side, my y value, that right there, this is the sine of theta. Okay. All right, so now let's go to the bottom left. There we go. Cosine theta from SOHCAHTOA is adjacent over hypotenuse. On the coordinate plane, here's my angle. This is the adjacent side, which is my x value, and then the hypotenuse is still my radius. So another way to look at cosine is x over r. It's a unit circle, so the radius is 1. So cosine of theta is x. Right. So the cosine of 2 pi, here's 2 pi thirds. The cosine of 2 pi thirds is negative 1/2. The cosine of 5 pi sixths is negative square root of 3 over 2. Okay? So we want to know our ordered pairs, where they land, what they're related to, because that gives us those sine and cosine values that I told you you're just going to have to know. Right? So that means that, let's move to the bottom right down here. Every ordered pair xy on our unit circle, it gives us the information of cosine theta, sine theta. Oops, my theta looks weird, but there you go. And to help you keep this straight, xy is alphabetical, so is cosine sine. Those of you in AP Physics, your mg cosine theta, mg sine theta, that's what all this is, that's where all this comes from, which it would have helped you greatly in physics if you had all this first. It's just not how it works out, sorry. All right, we all good with that? Okay, so on delta, we're not done, but Your assignment today is in Delta Math. I do not expect you to know these. I don't even want you to try and memorize them because I want you to do it my way, basically. So, but it's going to ask you, what is the cosine of this? What is the sine of this? I want you to be able to use this to answer those questions, right? I want you, if it says, what is the cosine of 7 pi fourths, you're going to find 7 pi fourths and know to get the x value. That's what I want you to be able to do right now. I also, a little disclaimer about Delta Math, you know how it tells you how to work the problems? I don't know if it's true on this assignment or not, but on some of them, when they're asking you about the trig values of radians, the way they tell you to do it is take the radians, convert them to degrees, then figure it out, and then like, no, bad, real bad. We're not converting to degrees unless the question says convert this to degrees, and that will not happen that often. So don't listen to them on that, all right? Delta Math's amazing, but sometimes they're like way off track on anything that makes sense, and that's one of them. All right, so we've talked about sine and cosine. Let's talk about tangent. Let's go to the top right up here. Okay, so tangent theta from SOHCAHTOA is opposite over adjacent. That's old business, right? We know that. Well, the opposite side in the coordinate plane is y, and the adjacent side is x. So tangent is y over x, which also means that the tangent of theta equals, what else does y equal? Sine, okay? Sine theta over x, which is cosine theta. So sine and cosine are right there in front of you in the ordered pairs. To find tangent, you just put sine over cosine. Y over x, just like slope, right? When you do slope, you put the change in y over the change in x. This is still y over x. That's another way we can keep it straight to know which one goes on top. We good? All right, now when you first learn the word tangent in geometry, you're not talking about trig, you're talking about circles, and you learn about tangent lines. Then you learn trig, and you learn tangent. You're like, these two things are completely unrelated. Not true. So let's see why tangent is called tangent. So I want you to take, so your ID makes a great straight edge. Well, first of all, how many times does a tangent line intersect a circle? Once. So at this point right here, if my pen was going to be tangent, it would basically just like touch it at that point, right? So we're going to do our best with our straight edge of our badge and our pencil to draw a tangent line. You're going to draw through your first ordered pair, which is fine. We can't really avoid that. So we're just going to draw a line that looks like that. Okay. Then reflect all of these down. Then you're also going to take, so like this hypotenuse here that goes through pi 6, you're going to extend it till it hits your new line, like that right there. And one of the things you also learn in geometry is that a tangent line drawn, let me back up. I can't even get the words out. A radius drawn to the point of tangency, so basically my radius and my tangent line intersect, they're always perpendicular. So I got a perpendicular line there. So now I want you to look at what I have. I have this original triangle we drew in that has that purple vertical line, and then I have another right triangle that goes out a little farther and it's blue, and those two right triangles overlap each other. Do y'all see that? Okay, so they're similar by angle. Since they're similar, we can set up a proportion. We're going to name a couple points first. This point we're going to name B. And this point right here that's messing up our first order pair, we're going to name A. Okay. Oh, and I forgot here, because I did sine vertically, this, your x value, this is cosine theta. I just didn't go back and write it there. So I'm going to set up a proportion. My first little triangle, I'm going to put sine over cosine. So sine theta over cosine theta equals. So if I put the vertical side over the horizontal side, then for my bigger triangle, I have to do the same thing. Vertical side over horizontal side. Well, we named the vertical side AB, so the length of AB, that's this one right here, the blue one. And then this side is actually the radius of the circle, so that radius is 1. So make sure the proportion makes sense to you, because y'all been doing proportions forever. This side over this side equals this side over this side. Do we all agree that that works? Okay. So AB over 1 is just AB. And what else does sine over cosine represent? Tangent. So that means that the tangent of theta is the length of AB. So this is tangent theta. Tangent is called tangent because the length is tangent to the circle. Okay, so they are related to each other. Same thing with secant. Secant intersects the circle at 2 points. And if I was to draw some other triangles on here, which we are not going to today, it would be way too much stuff right now, that there's a secant, the secant value is part of a secant line that intersects the circle twice. So, yeah, tangent, the tangent, that's not how we're going to find it, but I just did want you on this, since we were drawing all this stuff, for you to see that there's a reason it's called a tangent line. Okay. All right, so I'm going to ask you a couple things. I'll give you time to put up, don't worry. But what is the cosine of 4 pi thirds? Cosine of 4 pi thirds. Here's 4 pi thirds. And what is it? Negative 1/2. Okay. What is the sine of pi halves? 1. Because here's pi halves. Sine is just the y value. Okay. So do you understand how to find the angles and pick which one you need off of there? Okay. That's what we need to practice. And I need you to actually practice. Like, if you haven't done any of the stuff we've done this week, you need to do that this weekend. The only way you're going to really learn this and become experts at it and it not stress you out is if you practice along the way with me. You got to trust me and stick with me. Okay? Are we good? Beautiful. Then y'all can go ahead and put your stuff up.